All right, so for this section 5.4, integration using exponential or e to the x, I'm going to do the notes a little bit differently. So again, I would highly suggest printing out the note sheet, and if not printing it out, then definitely writing it all down in your notebook, because the best way to learn this stuff is to actually do it yourself. All right, so there's a couple properties up top here that are just review in terms of stuff that we've covered in the past. These are just properties of exponentials. But the main thing to remember is when we had taken the derivative of e to the x, the derivative of e to the x was e to the x times the derivative of what was in the exponent. So now we're reversing it. And we are going to be taking the integral. So the integral of e to the x is still e to the x. The only extra piece is, just like when we did natural log, if there was anything extra in the natural log, you had to make sure that you were using u sub, and the same goes here. So if there is anything besides x in the exponent for an exponential, you have to use u sub for each and every one of these. So I would anticipate that being what you're going to have to do in most cases, because they are not going to be just basic e to the x functions. So for example, we're doing indefinite right now. We'll do some indefinite and then we'll do some definite integrals. So A says we have the integral of e to the 3x plus 1. So it is not just the integral of e to the x, which means whatever is in the exponent is going to be your u value. So u is equal to 3x plus 1. Therefore, the derivative of 3x plus 1 is 3 dx. The 3 is not relevant, which means we're going to bring the 3 to the other side, making 1/3 du dx. When we sub everything back in, we have e to the u times 1/3 du. The 1/3 can now be kicked out in front. And when we take the integral of e to the u du, well, the integral of e to the u is like the integral of e to the x. It's just 1/3 e to the u plus c. And then your last step would just be to sub back in what your initial u value would be. Again, make sure with the indefinites you still have the plus c on there. All right, for b, again, always start off with the exponent as being your u value. So u is equal to negative x squared. The derivative would then be negative 2x dx. The negative 2 is not needed in the question, so we're going to bring that over. What else, though, is in the question is this 5. So I had done it on the right-hand side there, but maybe bring the 5 out, just because it's not even part of the question, and it's just sort of like a leading coefficient. So after we divided by the negative 2, so we have negative 1/2 du equals x dx. That's good, because if you look at the question, we have an x, and we have a dx going on here. So when everything gets subbed back in, we have the 5 outside. We have the integral of e to the u, and then we have negative 1/2 du. Now that negative 1/2 can come out with the 5, so it's negative 5/2. The integral of e to the u du. Integral of e to the u is e to the u, and then last step is to sub it back in. And the only thing you have to do after this step, which it doesn't show here, is you have a negative exponent. We can't have negative exponents, which means we need to write them so we have positive. So the negative 5 is going to stay in the numerator, and then the 2e to now the positive x squared is going to be in the denominator. All right, for the next 2, we'll do indefinite on one of the videos, and then we'll do definite on another video. All right, for the next one, again, start with the value that's being in the exponent for the e function. Start off with that, see if that one is going to work out. So we have u being 1/x. Well, we know we can't have x in the bottom, so we're going to bring it up, making it x to the negative 1. The derivative of x to the negative 1 is negative 1 x to the negative 2 dx, and we're going to bring that x to the negative 2 down. And that is part of the question because that x squared is in the denominator of the original function. The only piece that is not needed is this negative, so we're just going to bring that to the left-hand side. And when we sub everything back in, we have the integral of e to the u, and then basically the 1/x squared dx is negative du. Now, if that's difficult to see, what you could also do is rewrite the question. So we have e to the 1/x, and then that's being multiplied by 1/x squared dx. If you take that numerator and move it to the side, that might be a little bit more clear, because now this was our u value, and then this value right here. So this was u, and then this was negative du. And then that's how we end up with this step right here. And then when you finish the integration, the integral of e to the u is e to the u, so you have negative e to the u, and then you sub back in your u value with the plus c. Now, even when trig gets put into it, you still start off with the exponent of the e function being your u value. See if that's going to work. The derivative of cosine is negative sine. We don't need the negative, so we're going to move that